Welcome to this online video tutorial. My name is Víctor Cutillas Juárez and I work under the supervision of Professor Amadeo Rodríguez Fernández Alba at the URL of Fruits and Vegetables. I will discuss the main differences between supercritical fluid chromatography and liquid chromatography regarding the pesticide residue analysis in food samples. For those who are not familiar with supercritical fluid chromatography, carbon dioxide is the most frequently used mobile phase in SFC due to its favorable properties like low toxicity, widely available, but most important one is it has a low critical point. When CO2 is put through specific conditions of temperature and pressure, it acquires a new density. Therefore, supercritical CO2 can act as a solvent, providing different separation than usual liquid chromatography. Also, it will have the capability to mix with a wide range of liquid organic solvents, being methanol the most common one. First of all, it's important to explain how this chromatographic comparison was carried out. This is a general scheme of how the Shimatsu SFC works, and there are three main differences compared to liquid chromatography. We have a CO2 pump, we have a back pressure regulator device, and also we have an auxiliary pump. So first of all, you need to know that you have two chromatographies in one system. This is the chromatograph that we have in our lab in Almeria. So if we shut down the two main devices of the supercritical fluid chromatography, I mean the VPR and the CO2 pump, we have basically a liquid chromatograph system. And this is how we perform our evaluations. We injected the vials using one chromatography, and then we change the chromatograph devices to perform the exact same experiment with the same vials, but using the other type of chromatography. Both chromatographies are coupled to the same mass spectrometer. It's an unusual triple quad. SFC does not need a specific mass spectrometer, and you can use a common electrospray ion source. Regarding software, as we are using a triple quad mass spectrometer, the data treatment is exactly the same as liquid chromatography. Regarding solvent consumption, here we can observe that the methanol solvent consumption is usually lower compared to LC, but there's no water consumption. Instead, we are using carbon dioxide, which is usually cheaper and can be easily recycled. Therefore, it's within the green chemistry movement. This is a chromatogram of SFC using 1.3 milliliters per minute of mobile phase. Dilution of compounds is different compared to LC. The compounds elute at the beginning of the chromatogram. This provides us faster analysis, but you need to take care of coelutions, and also there's an important fact regarding retention times. This is one of my favorite slides because it explains how the chemical properties of the mobile phase in SFC can make it so unpredictable. Regarding retention times, we can observe that when we analyze pesticides using reverse phase LC, compounds elute in a decreasing order of polarity. However, in SFC there are a lot of factors involving dilution, so SFC does not follow just this polarity elution criteria. Compounds eluting late in SFC can present bad chromatography or even carryover. So this is an important factor that sometimes is quite random. This is a scheme of the elements that involve the retention time in SFC, mainly because these factors modify the density of the mobile phase directly or indirectly. In addition, it's important to understand that there are some differences in the ionization at the ESI source. Most of the mobile phase in supercritical fluid chromatography is carbon dioxide, but this loses its supercritical state before reaching the ion source. It does not work anymore as a solvent, so only a small amount of methanol with the compounds reach the ESI source. And that's one of the reasons of why it's necessary to use a makeup or auxiliary pump. Nevertheless, the flow rate still will be lower than LC, and this has some ionization benefits. This higher ionization efficiency, it can increase sensitivity, but also allow the better ionization of some compounds not commonly analyzed by LC, like pyrethroids, which are usually analyzed by gas chromatography. Here you can observe how we added most of the pyrethroid pesticides to our multi-residue method. Also, this better ionization and sometimes the different elution mechanisms of SFC lead to a reduction of the matrix effects. This is a very well-known advantage of SFC that could be useful in the analysis of complex matrices. Chiral separations is another very well-known feature of SFC. Maybe you have a particular challenge regarding isomer separations, and SFC could be useful for you. Regarding injection volume, we inject 2 microliters in SFC because the system provides us enough sensitivity to reach our limits of quantifications. However, higher volumes can be injected. But it's necessary to take into account that if the vial solvent is quite different compared to the mobile phase, like 100% of water, it can produce a decrease in the quality of our chromatographic peaks for some compounds. So, as a summary, do I need supercritical fluid chromatography? Which scope do you have in LC? Is there any pesticide that you miss in LC that maybe it can be quantified through SFC? Do you analyze complex or easy matrices? Do you have any difficulties with a particular matrix? Do you have performance problems of compounds using LC, carryover, or poor chromatographic quality? Maybe SFC can be the alternative to liquid chromatography that can fix these difficulties. In the next slide, I will present some questions regarding the topics presented. Hope this tutorial was useful for you, and thank you for your attention.